Hello friends, welcome to Graph+AI 22 Summit organized by Graph. I'm here to present one of my latest project, P2P.ai, a complete data science framework to manage finance and supply chain procure-to-pay operations. My name is Amit Shukla and you can find me at GitHub, Amit X Shukla. I have authored 30 plus community source projects, including a couple of my recent projects in Julia language, ML4GL and Procure2Pay.gl. This project P2P.ai is totally based on Procure2Pay Julia language package. In my career, I have done tons of finance and supply chain ERP implementation for very large organizations. Recently, during this hackathon, I came to know about Tiger Graph. So I thought, okay, why not use graph analysis with data science framework in ERP domain? So in next few slides, I'm going to show you how you can use data science technologies to understand, predict, and perhaps prevent global supply chain shortages, especially using ERP data. Whatever I'm going to discuss today and all the ERP implementation, everything is included into the documentation, and you will be able to find entire source code in my GitHub repository. The documentation you will see, it is published under GH Pages branch of GitHub repository. As you might notice that this is developed in Julia language. However, I could have used the Python. The only reason I'm using Julia language because ERP data often requires you to work with terabytes of data. So Julia has a built-in distributed parallel numerical computing. This is the reason you can achieve, if you're using Julia language, you can achieve performance which is very close to C or C++. If you go through my documentation, you will see tons of real life data. These are not the actual data, but very, very close to the real supply chain data. As you can see, you will find examples of the real GL balance sheet, income statement, cash flow, even same as the supply chain data model. You will notice that these examples are executed. So what that means, this documentation includes executed code. The whole purpose of this project is to solve some real-life problems which are related to finance and supply chain data. So first, we need a place where we can store petabytes and terabytes of data. Most of the time, ERP data are huge data sets. So that's where Tiger Graph comes in. And not only stored, you want to run some analytics. You want to query those data ad hoc. And then you want to run some predictions on that so that you can push the alerts. You can create some real-time predictive analytics and you can show it to the business so that business can take informed decisions. So this whole P2P.ai project is not only confined to the Oracle. You will see a lot of examples from Oracle and PeopleSoft. But the same thing, as long as the data set is finance and supply chain in nature, this whole P2P.ai package can be applied. And the market, most of the places where efficient supply chain procurement process is required, that's where this package is applicable. All right, let's dig in a little bit how a typical finance and supply chain business process look like in an organization. Depending on the organization, this diagram may look entirely different. But most of the time, good news is most of the big organizations have their procure-to-pay operations, business processes very well defined, very well documented. And that's how they have implemented the big ERP system. So most of the time, it always starts with their equations or a material service request. So the people who are responsible for buying the goods for your organizations, they create MSR equation. It goes to the vendor and vendor sends the good. Upon successful receipt or receiving, most of the time, those automatically, the invoices are created and vendor gets paid. And after the vendor is successfully paid, everything is recorded into the general ledger. Of course, there are some other supporting modules like travel and expense, operating expenses, time and labor, etc. But a typical business process looks like this. You have your procurement process, your payable process, your receivable process, your revenue process, and then you have trial your expenses, and heart of it, you have accounting process. Most of the ERP systems like Oracle, PeopleSoft, SAP, or JD Edwards, one thing you will notice that they use RDBMS structure. And that's because the RDBMS has been very, very popular. It's a very efficient method to store big data set in SQL tables. And it's also very convenient to query the data. And the reason is because the data is highly integrated. There's a relationship between the data. So for example, if you're looking into this example, you will see there are typical chart field dimensions like account, location, department, cost center, fund. And the same thing for supply chain, that you have your vendor dimension. Some people call it a chart field, vendor, item, payables, and then you have transaction tables. So for example, purchase order, sales, revenue. So in sales register, if you're selling something, if you're generating revenue, you capture your sales transaction into sales registers. But most of the time, the data looks like this. They are structured in an RDBMS tables. And the reason is because they have, you can join the SQL tables very easily. However, this works very well if you are working with, if you are trying to generate ad hoc queries or say, doing some simple analysis, ad hoc reporting, it works very, very well. But when you want to do some typical analysis, then it becomes a bottleneck. Let me show you one more example. So this is another data set. So for example, in your vendor set, this is a vendor master, location master, buyer master. Typically, if you dig a little bit deep, your item. So for example, the goods you are selling. I'm just taking an example from the pharmacy and pharmacy. The typical example, it may be very, very complex. So just to give you an idea, for example, it's possible to have that you have 1 million type of different items in your organizations. So for example, most of the healthcare organizations, if you look at just the UNSVSC code, there are a couple of thousands UNSVSC code out there. So most of the product, they fit into those categories, and then most of the products have types. So a product or an item could be a very, very complex thing. Same thing with the vendor. Vendor could be very complex. It's not as simple as that. There's one organization, it has an address. No. Nowadays, the organizations work in different type of business units. They are distributed all across the world. So, and different depending on where the organization, where your vendor is located, the tax laws could be different. So, long story short, the finance and supply chain data could be very, very extremely complex. However, ERP, they are great systems when it comes to the capturing the data. So, but when it comes to the understanding the data, you need another kind of a analytics method so that you can drive the meaningful analytics from that data set. And that's where the graph comes in. If you talk to your financial accounting executives like CFOs and maybe CEOs or CEOs, everybody is so used to seeing the information in this way. So for example, look at this example. Most of the finance, they revolve around these three statements: cash flow statement, balance sheet, and income statements. And that's what you submit to your SEC filings. Now, this format has been extremely popular. Most of the financial executives are so used to seeing the information in this way. However, this is a very efficient way. I'm not denying that. But what happens if you want to get some insights, create some analytics from this data? Then this typical RDBMS, if you want to run some analytics on these financial statements, it becomes very, very hard. It becomes very inconvenient. Or perhaps you have to hire another analytics tool or transport this data to another analytics system and then run your predictive analytics. Let me give you another example. So for example, if you start thinking from a fresh perspective, what if I could have uh, plotted this in a graph? So what you're looking for, so for example, if I take that ledger data and create a vertex out of it, location becomes my vertex, account becomes my vertex, and department becomes a vertex. And then you define your edges, your relationship. Because most of the time, your department, you want to see your data by department, by cost center, by account, by location. Traditionally, you can always do that using SQL. But using SQL, it helps you create those executive statements, but it doesn't help you get those insights, those analytic insights from your data. Let me show you one more few examples. So if you plot your data, if you store your data in such a way in these vertices and edges, then you'll be able to answer this kind of question. So for example, during recent pandemic, you want to know, hey, now the pandemic is not over, okay, but still what it takes to most of my employees have been working remote. So last couple of years, nobody's coming to the office. What does it take to take some of the people, half of my, or maybe 25% of my workforce, get back to the office? How much is going to cost me? Or is it a good idea to allow people or bring back people back to the office? What is the actual saving in operating expenses if financial executive decides to do that? So for example, if 1/4 of location in California are permanently closed, how much I'm going to save in operating expenses? Now, another query for this is one very good example. If employees didn't travel in the year 2020, 2021, or maybe like first quarter of 2022, how much savings I have done in travel and lodging? And how much is going to be travel cost should be expensed back to the employee as a perk? Well, that's an exaggerated idea, but still. So based on this typical RDBMS, if you store your data in typical RDBMS, it becomes very hard to answer this kind of questions because you have to do the analysis. You need to one hop or two hop. Well, that's in the terms of graph and analogy. You have to get the business insights from the graph perspective. I want to call out, if you go through my documentation of my GitHub repository, so these are the exact queries. So what I did, I tried to load actual data set to this graph and I tried to create a couple of queries. Not everything is a working example. I apologize for that because this is a work in progress package, but it will give you an idea. So that's exactly what I tried to do. I tried to create those GraphQL queries so that I can, help answer those analytical questions. Now let's take another more complex example from the supply chain perspective. All right. So supply chain graph, it could be very complex. Again, depending on your business process and your data structure, it could be extremely complex. So the graph, what I try to load into Tiger Graph database, we created a lot of purchase order transactions, sales transaction, MSR transactions, and then we created a lot of vendor master, item master, and a lot of vendor or item related attribute information. So for example, an item belongs to a UNSPSC category. An item can have a GUDID database, or it could be tied up to a particular GTIN number or vendor identifier number, vendor manufacturer part number. So there are different type of attributes. Again, all of this graph, this is a sample graph. The entire graph, it may look entirely different depending on your data set. But this is one of the typical example you will be able to find in my GitHub repository. These are all the data set, and you will also find some sample data in my GitHub repository. I didn't, because GitHub doesn't allow you to upload gigabytes of data, but I have included the script which you can use to create those giant amount of data if you need to. So, but you will find samples over there. I have so for example, ship receipts, organization master, and then I tried to create those vertices and edges, and then I wrote a lot of different queries on those on this supply chain P2P graph. Let me go back to my documentation one more time so that I can show you a couple of query samples. Right, so here you can see, so same thing with the supply chain. Suppose you want to know during 2020, that's when the pandemic is believed to be started, what are my UNSPSC category experience higher surge in source orders? So remember those times, that's where the whole package, I wrote this, I gave this a name $1 billion toilet paper. So if you remember, like during that time, like a lot of people were like, everybody was crazy trying to find toilet paper in those shelves, if you remember those empty shelves. So that's where this idea came from. I was trying to do some analytics, where did those kind of items which are essential to our daily use, where did those items go? Toilet paper is an exaggerated example, but think about like some life-saving drugs. So for example, remdesivir, ibuprofen, and it happens every time. Every time there is a COVID surge, you will notice that there are certain items like ibuprofen or maybe all the cold related medicines, those disappear from the shelf. So the whole idea was, if I could solve, if I can try, if I can figure it out, what are my items which may experience a deficit, an increased demand, what are those items so that I can plan in advance? So for example, in 2020, if you might have noticed, all the cleaning supplies categories, all those items were sold a lot more than average. And I have the data, which I believe, like, most of the like hand sanitizer, surgical mask, most of the pharmacies and even the big stores like Walmart or Target, they have seen that there were 600 to 6,000% more demand, especially related to the cleaning items. So so the whole idea of using this graph supply chain theory is to trying to figure it out, what are those items which are requested more and in which category. So what happens if we can predict, if we can use this package and especially the graph technology to figure it out, what are the most requested items, so that we can, the whole idea is to trying to figure it out, those items which belongs to controlled substances or life-saving drugs, which are really very important to human survival. So I want to continue, and I want to mention one more thing here. There are a lot of simple queries, and you might question, hey, you know what? I could have written this simple query in a SQL database. But These are the simple queries. Again, you can write the same. It's all about the getting the information, retrieving the information from your database, how fast you receive that information, and then you run analytics on top of that. So once you get those data, then you want to run your analysis. Would have, could have, should have. So for example, what if this particular region A, and it happens all the time, is merged with region B? Okay, what if employee resume work from office? How much travel amount is going to increase? Let's take a couple of more supply chain examples. So for example, was there any decrease in implants? In other words, were there any cardiac or other critical operational surgery delayed during COVID? And that happened a lot. A lot of time what happens, if you remember during the start of the pandemic, they would say, hey, COVID is there. So a lot of clinical operational surgeries were delayed, because they said, hey, it's not that critical. But actually, it's not. All the operational surgeries are critical. So that shouldn't have happened. Anyway, um, the whole idea is using this graph analysis, using this procure to pay supply chain data, and trying to figure it out, trying to answer this analytical question. And once we can run this advanced analytics, perhaps we can plan for doing something extra. So for example, I tried to create, sorry, I didn't finish all of those notebooks here, but couple of notebooks I wanted to, I want to showcase this to you. So how can we take all of this graph data? And the good thing with graph theory is with the tiger graph, it comes with a data science framework built in. So what if I can take the data from the graph database itself and can run an AI machine learning algorithm and can run my predictive analytics right there? And the whole idea is once you get your predictions based on your machine learning model right from your graph database, so that you can display to the business immediately. So this repository is a work in progress. I request you, if you are interested, please feel free to fork this, please feel free to connect with me, please feel free to contribute. And I'm looking for open source community developers who are willing to contribute to this GitHub repository. Well, I have a lot to cover and a lot to talk about, but unfortunately, we won't be able to cover every detail in this talk today. But the whole idea is I wanted to give you a glimpse of the project, what I've been working on, and you'll be able to, as I said, I keep on repeating that you'll be able to find entire source code to the GitHub repository. And if you're interested, please, if you want to contribute, please feel free to reach out to me. The whole idea is I want to take this package forward. I want to deploy it as a guided buying system, or maybe just an open source community project, which a data science framework kind of a project, which people can take it off the shelf, put it, apply it onto the data set, and just create those predictions and run those notebooks out of the box. I have a lot of different things planned for this project. As you can see, I only worked on a couple of notebooks, but there are a lot of different notebooks. I have ideas I want to implement. So I'm looking for contributors. Please feel free to reach out to me. So at last, I want to thank you for watching and thank you for your interest. Thanks for listening to me. If you want to connect, these are my, you can reach out to me at Twitter. You can reach out to my YouTube channel and or GitHub repository. I'll be happy to connect with you. If you have any questions, now I'm ready to take this. Thank you very much.